Hi there, math students. We are looking at the normal distribution and empirical rule here. And our goal in this video is to go over this, which was an assignment my students did. And if you want to try these problems yourself, if you haven't already, I'm going to, as I move this up and go to each section, I'm going to pause for a second, let you hit pause yourself and try the problem so that then when we go over them together, you know whether or not you got it going on, basically. All right, so first off, remember that we have the information that if we have a normal distribution, the empirical rule says this is true, that 34% of the data falls between one standard deviation below the mean and the mean. This is the mean right in the middle. 34% of the data stands between the mean and one standard deviation above, and so on. This basically is the area under the curve indicates the percent of your data points that will fall in that area, in that specific region, in that range of values. So, in a basic normal distribution, what percent of the values lie below the mean is number one, and number two is above the mean? Well, notice that it's symmetrical, and that's a big deal. That's not by accident, okay? That's part of what makes it a normal distribution. So that means half of your stuff, half of your data is to the left of this, and half of your data is to the right of this. So that's 50%. So that's 50% for both of those answers. So this would be 50% here, 50% here. All right, what percent of the values lie within one standard deviation of the mean? Okay, when it says within one, that's kind of like if I said, I want to go to a gas station that's within 5 miles of my house. That doesn't tell you a particular direction. So within one means it could be one this way, or it could be one this way. In other words, it could be up to one standard deviation higher than the mean, or it could be down to one standard deviation below the mean. So within one standard deviation is from here to here, and that's 68%. The next couple of questions ask very similar questions about 2 standard deviations of the mean and 3 standard deviations of the mean. Okay, so those are basically these other intervals we have described here. From 2 standard deviations below to 2 standard deviations above, 95% of your data is in there. And if we added up these numbers, that would all come to 95%. From 3 standard deviations below to 3 standard deviations above, that's this right up here. That's 99.7% of your data. So 95% of your data is here. 99.7% of your data is there. Next, we're going to actually apply this to a specific situation. So if you have not already done this worksheet, I would suggest you hit pause, fill in the values on your standard normal curve there that's shown. In other words, we're going to put numbers under each one of these little tick marks here. And I actually will probably draw some vertical lines to help me as well. Okay, so let's do that. 2,000 freshmen at State University took a biology test. The scores were distributed normally. That's the first thing, is the fact that it says that is what tells me I can do this. With a mean of 70, that's right in the middle, and a standard deviation of 5. That means each of these regions, the width of each of these sections is 5. So this is 70 plus 5, and then plus 5 again, and then plus 5 again. 70 minus 5, and then minus 5, and then minus 5. One thing that I want to point out about this is that this particular picture, this particular graphic, makes it look like the curve touches the x-axis. It doesn't, or touches the horizontal axis. It doesn't. The curve never meets the horizontal axis. It looks more like this illustration, where it keeps getting closer and closer and closer. It's like an asymptote, and it never touches. So just keep that in mind. It looks like it touches here, but it does not. Okay? So now let me go ahead and draw those vertical lines I was talking about, because I like to see the sections. And I'm doing this from the side, so they may not be the best vertical lines you've ever seen, but there we go. And then the next thing I'm going to do is I'm going to fill in all those percentages. So 34%, 34%, and remember those just come from what I already know about a standard normal distribution. Those same exact values. The only difference between the chart we're looking at right here and the chart that I keep moving over and showing you is that this one has specific values here. I filled in the mean and marked off what 1 standard deviation above the mean is and what 2 standard deviations above the mean is, etc. So this is 2.35%, and this is 1.15%. Okay, so that's the first step, is let's fill that in. The next step is to use that now to go ahead and answer these questions. So let me move up the questions so you can see them, and if you want to, go ahead and pause your video right here and try those. All right, so A, what percentage of scores are between 65 and 75? Well, those are 1 standard deviation below to 1 standard deviation above. Those are the 2 regions that add up to 68%. So that's my answer for number or letter A. What percentage of scores are between 60 and 70? Well, that's me adding 34% and 13.5%, so it's 47.5%. What percentage of scores are between scores 60 and 85? Well, that's a bigger group. So 60 is 2 standard deviations below to the left of the mean, and 80 is 2 standard deviations above. And remember, within 2 standard deviations, that's 95% of your data. So between here and here is 95% of my data. But they said between here and here. So let's just add on that 2.35% and I get 97.35%. You could also just add up all of them. Part D, what percentage of scores is less than a score of 55? Well, that's right here. So that's 0.15%. Part E, what percentage of scores is greater than a score of 80? All right, so that's these 2 sections here, and those 2 sections always add up to 2.5%. Part F, approximately how many biology students, scored between, I've got speakers in my way, I'm trying to get out of the way. There we go. Approximately how many students? How many students is a different question than what percent. And what percent is what this tells me. So in order to know how many students, I'm going to have to figure out what percent, but then I'm going to have to go back up here and use the fact that the total number of students represented by the entire chart is 2,000. Okay, so F, approximately how many biology students score between 60 and 70? So the nice thing about this one is we already know what percent of students score between 60 and 70 because it's right up here. So we need to take that percent and say we're looking for 47.5% of the 2,000 students that are represented by this entire chart, by this whole distribution. So 47.5% of 2,000. Don't forget that you can't ever use a percent without changing it to a decimal first. So this is what we have, and that gives me 950 students. Same thing happens in G. I need to figure out what percent is between 55 and 61st. That's 2.35%. Change it to a decimal. That's 0.0235. Multiply it times 2,000 students. So 2.35% of 2,000 students. Well, obviously and that should let me know it's definitely not going to be 4.7 students. Let me know I left off a 0, so it's 47 students. Okay, 47 students. And those are my answers. Next, we have another example that's very similar. So let's try that. Here is your setup and your curve. If you haven't done this problem yet, go ahead and try it now. Hit pause. If you've had a chance, let's go ahead and catch up with you. 500 juniors took the ACT. The scores were distributed normally, which is saying that I can do one of these. Fits the normal curve with a mean of 24 and a standard deviation of 4. Okay, remember mean is mu here and standard deviation is sigma. So here we have 24. Standard deviation of 4 means 4 to the right is adding 4, adding 4, adding 4. 4 to the left means subtracting 4, and so on. Okay, and again, this should be off the ground here. This should be, there is space to the right of this and to the left of this. It's just really close and we can't see it. Okay, again, I'm going to draw my vertical lines just because I like them. Helps me keep the sections separate. And I'm sorry if those are not the best vertical lines. They're not bad. And fill in my percentages. If you ever look at other resources for this, you might see some very slightly different numbers here because these are really rounded percentages. So occasionally you'll see somebody trying to be a little bit more accurate, but these are the ones that are probably used the most as just a general standard, especially in high school classes. All right, so we are ready to go now. If you haven't already tried to do these problems, here are the first several. You can hit pause and try them. First one for us says, what percentage of scores are between 20 and 28? Well, that's those two middle sections, and those add up to 68%. What percentage of scores are between 16 and 32? Well, that's from 2 standard deviations below 24 to 2 standard deviations above 24. That's 95% of the data. What percentage of the scores are between 16 and 28? I just basically have to add up these 3 sections. That's 68, and then I add that, I get 81.5. What percentage of scores is less than a score? Well, I guess is less is fine. Really, it's kind of no. I guess these might actually be is too. I got sidetracked thinking about the grammar there because percentage is percentage plural or singular. Let's just go with worrying about this part of it. Less than a score of 12. That would be 0.15%. Greater than a score of 24. 24 is the mean, so that's half of the data. Half of the data is always bigger than the mean, and half the data is always smaller than the mean. Now we get into the how many questions. How many means I need to take those percents and then actually figure out that percent of 500, because this whole distribution is representing 500 students. So between 24 and 28, between 24 and 28 on my picture, I've got 34%. So I need 34% of 500. I'm going to figure out where I just laid my calculator. Oh, here we go. And type in 0.34 times 500, and I get 170 students, or juniors. Approximately what or how many juniors scored between 20 and 28? Well, 20 and 28 we just talked about up there, that's 68%. So 0.68 times 500, that would be 340 juniors. Sorry about my juniors there, it looks pretty wretched. Approximately how many juniors scored between 24 and 32? That's 34% here plus 13.5% here. That's 47.5%. And 47.5% of 500 would be 0.475 times 500. And that's 237.5 juniors. I'm just going to leave it like that. You could say 237, you could say 238 because the question asks approximately. Approximately how many juniors scored between 16 and 20? 16 to 20 is 13.5% of my scores. So I'm going to do 0.135 times 500 and get approximately 67.5 juniors. Again, it would not be terribly wrong to say either 67 or 68 instead, since we don't have 0.5 of a junior. And finally, approximately how many juniors scored higher than 32. Higher is always to the right, lower is to the left. So higher than 32 is these two sections here, 2.5%. So 2.5% of 500 becomes 0.025 times 500. And that will give me 12.5 juniors. All right. Next up, last example. Again, we're with 500 students. We've got 500 freshmen this time. 500 freshmen at Schaumburg High School took an algebra test. The scores were distributed normally with a mean of 75 and a standard deviation of 7. Label the mean and 3 standard deviations from the mean, which is basically what we've been doing to every picture. That's what they're asking. So pause and do it yourself if you haven't already. For those of you who have, my mean is at 75, standard deviation is at 7. So 7 up from that is 82, 89, 96. Down 7 is 68, 61, and 54. All right. Let me go ahead and fill in my percentages. This is 34%. And honestly, by the time you finish writing this number of times, you probably have them memorized, which is a good thing. It's a dot. Okay, what percentage of scores are between the scores 61 and 82? Well, these two are 68 together, plus 13.5, that's 81.5%. Sorry, I did not give you a chance to do the problems. For those of you who haven't tried them yet, go ahead and hit pause and then resume when you're ready to. What percentage of scores are between 75 and 82? 34%. What percentage of scores are between 61 and 89? That's 2 to the left and 2 to the right, which is always going to be 95%. What percentage of scores is less than a score of 61? That would be these two guys together. That's 2.5%. What percentage of scores is greater than a score of 96? That's 0.15%. And now we get to the ones where it's how many. So we get to actually apply those percentages to the number of total freshmen represented by this curve, which is 500. So approximately how many students score between 61 and 89? Okay, 61 and 89 we have right here is 95%. So how many would be 95% times 500? And that is 475. Approximately how many algebra students scored between 68 and 82? 68 and 82, those are the two on either side of the mean, which is 68% put together. So 68% of my 500 is what I'm going to have. So 0.68 times 500 gives me 340. H, approximately how many algebra students scored between 61 and 75? 61 and 75, we've got 13.5 plus 34. That's 47.5%. So I'm going to take 47.5% of 500. And that gives me 237.5. Okay. Approximately how many algebra students scored between 89 and 96? Well, between 89 and 96, we've got 2.35%. That's right up here. When we change that to a decimal, remember you always move the decimal 2 places to the left. So it's 0.0235 times 500. And that gives me 11.75 people. So I might be really likely to go ahead and round that to 12. because it's approximately. But you might really, I mean, I'm fine with any of it. If you are doing this kind of thing for a different teacher, I would ask them, how do you want me to deal with items that we don't do fractions of? We don't do fractions of people. We don't usually answer a question and say 11.75 people. So do you want me to do that, or do you want me to go ahead and round? Finally, approximately how many algebra students scored higher than 89? That's these two sections together, and those two sections together add up to 2.5%. So I'm going to do 0.025 times 500, and my final answer is 12.5 students. Okay, now I hope this has been helpful to you. I do have a couple of questions I want to show you, just to give you a more of a little challenge here, just to think about. Actually, it's just more food for thought on how normal distributions work. The first one is this. I want you to look at that, and I want you to, after you hear my question, hit pause and think about it. I want you to think about which of those two curves has a higher mean, and which of those two curves has a bigger or a smaller standard of deviation. So remember that the mean is the middle of your graph. So here the mean is maybe 40, and here it might be 60. So this one has a number 2 has a higher mean. Graph number 1 has a lower mean. So mu is lower for 1 and higher for 2. Now let's think about standard deviations. Basically, if you haven't seen on the last video I did on this, I showed you a sort of a little demonstration on Desmos of how the graph changes as the standard deviation size gets bigger. When the standard deviations are narrower, what that does is it pushes the graph up. It makes it all closer to the center, and so it's really high in the middle. As the standard deviations get wider, and this is really kind of, what's the word? Misleading, because it implies each of these two have the same standard deviation size, but they don't. Basically, the fact that they're giving us 50 standard deviation here, it might be that the standard deviation on this one is like here, really. And here it's like this. So just because they're going by 10s on the graph does not mean the standard deviation size is 10. But you kind of want to treat it that way first. So standard deviation is smaller here because it puts all the data closer to the center. The larger the standard deviation is, remember standard deviation is sigma, then the more spread out your data is, and spreading the data out makes it wider. Okay, so looking at this one, I want you to decide which of them has a larger or smaller mean, and which of them has a larger or smaller standard deviation size. Basically, B, C, and D all have, no, I'm sorry. Yeah, B, C, and D all have the same mean. A has a smaller mean than either B, C, or D. Now, standard deviation size, the biggest standard deviation on this would happen for graph D. The size of the standard deviation for D is very wide. That's why it's very spread out. It's sort of flattened that curve. The next largest would be C. The very smallest standard deviation would occur on B because that's the one that is tallest. All right, now another type of question that you might sometimes see with these is something like this, where you are told, here's a shaded area, tell me what % of your data is in the shaded area. So I would suggest you go ahead and look at these two and see if you can tell me, you might want to hit pause, see if you could tell me what % of the data lies inside the shaded area. And then here's another one. See if you could tell what % of the data lies in the shaded area there. So hit pause now if you haven't already, because I'm about to talk about the first one. So looking at our standard normal graph, which I've put somewhere, this part is 34% and this part is 13.5%. So I would say 47.5% of my data lies in that area. It's really the same thing we've been doing. This one, the whole left side, this is the mean. And everything to the left of the mean is shaded. So that's 50% of the data right there. And you could also say 50% is unshaded. Last one, these two, remember, are 34% closest to the mean. So that's 68% together. And add 13.5% to that, and you get 81.5% is shaded. I hope that helped you, and you are good to go with the normal distribution problems that you need to do. And if you need to, look for another video for me. Remember, we talked about how on all of these that we've been doing, the reason we're using the empirical rule, which is just these percentages, given the way they are, the same percentages every time, is because we were able to, because all these questions asked specifically about numbers that I have right here. If you are asked for numbers that are not one of these, in other words, not one standard deviation above or below, or one within 2 standard deviations, or not those specific spots where it's exactly 1 standard deviation between any 2 numbers. Okay, if you were asked, for instance, what percentage of students scored less than an 80? 80's not up here. It would be somewhere in here, right? Or what percentage of students scored between a 60 and an 80? Well, that might be somewhere like here to there. If you're asked about that, you need to do something called a z-score. So if you're being asked questions like that, go look for my z-score videos, and hopefully those will help you. Thanks so much for coming. Thanks for watching. Thanks for working hard on math, and I will see you next time.